Welcome to the S2 Media Dispenser Technology Close-Up. This video will provide an overview of the S2's characteristics. The S2 is designed for use in NCR self-serve ATMs, both front access and rear access versions. Up to 4 currency cassettes can be installed in an S2 media dispenser. It is designed to support either a 2-high or 4-high PIC module configuration, depending on the actual needs of the customer. The currency cassettes are longer than predecessors, allowing for increased note capacity. NCR engineers designed the S2 for extensive remote diagnostic capabilities. Sensors report the status of all critical functional systems. Sensor data is recorded and tracked over time, allowing for monitoring of degraded performance that might be an early indication of pending equipment malfunction. The S2 has 4 main assemblies, which include the presenter, the nose, the PIC frame, and the PIC modules. On this side, you can see the main control board and various sensor boards on the PIC module. The main harness provides power from the self-serve DC distribution subsystem, USB communications with the ATM core, and also includes the cable for communications with the dispenser shutter in the fascia. Looking at the opposite side of the unit, you'll see the gears and belts that drive the PIC transport. The vacuum subsystem that is used to pick the notes is also found on this side. Currency cassettes or media cassettes are held in place by latches on the PIC frame. To load or examine the media inside of the cassette, press down on the green tab, pull out on the bottom of the cassette latch, then lift the top of the latch away from the cassette lid. Guide rails inside of the lid and base are used to keep media neatly stacked inside of the cassette. The position of the rails can be adjusted to accommodate different sizes of currency and media. A spring-loaded push plate presses the media against the opening at the front of the cassette, allowing the media to be picked or pulled out of the cassette and transported through the dispenser. A latch at the back of the cassette holds the push plate out of the way when loading or restacking media within a cassette. Press and hold down the green button on the push plate, slide it fully to the back, then release the button. When finished, push down on the green button to release the latch and apply pressure on the media. A spring-loaded garage door at the front of the cassette is forced open when the cassette is inserted into the PIC module. The door closes when the cassette is removed from the PIC module. This prevents accidental loss of currency from the cassette. The system uses logic and input from the vacuum sensor to determine when the cassette is empty. Various denominations or types of media can be loaded into a cassette. A rotary dial with 12 settings is used to identify the media type. The dial is held in place by a cover which is retained by a clip inside the cassette. The dial is rotated in the cover to change the setting of the cassette. A sensor in the PIC module reads the setting on the dial and informs the software. The software correlates the numeric code to a currency value. The PIC frame is relatively simple. As the name implies, the PIC frame is primarily a frame that houses the cassettes and provides a mounting point for the more complex PIC modules. The same version of PIC frame is used on 2-high, 4-high, front access, and rear access S2 media dispensers. The PIC frame slips into place on the presenter on 4 mushroom studs, 2 on each side. It is secured by 2 screws, 1 on each side. There are several components mounted on the PIC frame. This is the dispenser control electronics. There are latches and sensors for each of the cassettes. Last is the dual cassette CIC sensor. These sensors read the setting on the rotary dial on the cassette to determine the type or denomination of the media in the cassette. The front of the cassette rests inside of the PIC module. The PIC module is where the complex work of picking and transporting media occurs. The upper and lower PIC modules are identical. The only difference between a 2-high and 4-high version of the presenter is that a 2-high will only contain the upper PIC module. A 4-high, like this one, will have a pair. Each PIC module has 2 identical sets of components. One is for the upper cassette position within the module, and another for the lower cassette. Mushroom studs on the sides of the PIC modules slip into notches on the PIC frame. Latches at the top edge of the pick frame clip over mushroom studs on the module above. The pick transport drive gears are visible on the left side of the pick module. A stepper motor located in the presenter provides the drive for these components. A belt transmits power from the upper cassette position to the lower. The vacuum solenoids, tubing, and T-connectors that supply the suction used in picking of notes from cassettes are also attached to this side frame. Notice the vacuum filter at the base of the presenter. This prevents dirt and debris from following the vacuum pump in the presenter. There are a number of critical components located between the side frames of the pick module. Two long fingers on the key plate slip into openings at the base of each cassette and force the cassette garage doors open. The pick arms and suction cups pivot back to reach into the cassette and pull a single note. The arms then swing forward toward the transport rollers, which grab the note and move it on its way. Notice the partial rollers on the two G wheels. The cutout allows the note to be driven deeper into the roller before being grabbed as the G wheels rotate around. Ramps behind these rollers drive the note upward where it is grabbed by the vertical drive belts for transport up toward the dispenser. The pick sensor located between the G wheel and the vertical transport is used to verify that a note was picked and has moved to the vertical transport. The right side frame is home to the stepper motors that drive the pick arms. There are separate motors for the upper and lower cassette positions. The quad CIC board contains sensors that detect the position of the pick arms and the G wheels. There are several field replaceable units, or FRUs, within the presenter. These are the single note transport, or SNT, the bill alignment module, or BAM, carriage, nose assembly, and purge bin. Notes first enter the presenter through the SNT. The stepper motor located under the SNT provides the drive for the transport belts in the SNT and the pick module. The vacuum pump for the pick arms is also driven off of this motor. The motion provided by the stepper motor can be simulated by turning the green handle on the side frame in the counterclockwise direction. The main timing disc and sensor, located in the lower front corner of the SNT, are used to verify that the main motor is providing drive to the transport gears and belts. On entry into the SNT from the pick modules, seen here from below, the notes first pass the Hall effect thickness sensor and width sensors. These sensors verify that a single good note is being transported. The media deflector is a bracket which provides a cage that prevents notes from flying upward as they exit from the SNT. This bracket retracts after the notes are stacked. Home and exit sensors track the position of the bracket. Rotating flicker fingers will aid in forcing notes down into a neat stack within the bill alignment module. At a glance, the fingers might be mistaken for a broken belt due to being similar in appearance to a toothed belt. In the base of the top section of the transport is the divert gate. If the thickness or width sensors detect a bad note, a solenoid will open this gate to direct notes down into the reject path to the purge bin. The BAM is where notes are stacked as they feed out from the SNT. These serrated fingers function as a gate to limit the flight of notes as they exit the SNT. The motor and gear are used to adjust the position of the BAM fingers based on the size of the media that is being dispensed. A sensor is used to track the position of the BAM fingers. The carriage assembly is the mechanism that moves the money from the BAM to the customer or, in some circumstances, to the purge bin. There are distinct versions for front access and rear access applications, but they are very similar. The lower section of the carriage transport is known as the clamp tray. This section is hinged to allow the front edge to be guided down into the BAM during a stack operation. So, in fact, when notes enter the BAM, they are actually being stacked onto the lower section of the carriage transport. The up and down movement of this clamp tray is controlled by a motor and cam mounted on the presenter core. The upper section of the transport is also hinged. This is simply to accommodate variations in the thickness of the note stack. Front-to-back movement of the carriage is controlled by an onboard stepper motor. A second motor with timing disc is used to control movement of the belts on the transport. In one direction, the transport will feed the stack toward the exit sensor. In the opposite direction, the stack is directed toward the purge bin. There are a total of 6 sensors in the carriage assembly, including the timing disc sensor already mentioned. The home target sensor is a CIC sensor that is used to ensure that the carriage is in the correct position prior to lowering the clamp tray for a stack operation. Whereas most of the CIC sensors in the S2 track rotational movement, the carriage home CIC sensor tracks linear movement. The bunch sensor is used to confirm that the stack has been clamped into the carriage and is ready for transport to the customer or purge bin. The pre-exit sensor is used for tracking movement of the notes toward the exit shutter. The exit sensor is used to monitor the removal of the note stack when it is presented to the customer. Located at the back corner of the carriage, the flag sensor is used to align the carriage over the return from present bin or purge bin, in preparation for purging the stack. The flags are situated on the lip of the presenter core above the carriage track. Purging notes is performed by starting the carriage transport motor and feeding the notes in the reverse direction to be deflected downward into the purge bin or retract bin. The purge bin sits inside the presenter above the currency cassettes. This is the collection point for notes that are not suitable for dispensing or notes not taken by the customer and retracted during dispensing. The purge bin is divided into 2, possibly 3 sections. At the base is the divert bin. This is where single notes are routed when they fail a quality check during transport from the cassettes into the dispenser. When the divert gate opens on the SNT, the bad notes end up here. Stacks of notes may end up in this area of the purge bin due to a canceled transaction, notes left at the shutter by the customer, or some other event. This area may be separated by a divider into 2 pockets. This smaller pocket is reserved for notes that are returned from present, meaning the customer left them sitting at the exit shutter too long, causing them to be retracted. The larger pocket would contain all other undispensed stacks, such as canceled transactions or notes left in the dispenser as a result of a power failure. The single note transport, bill alignment module, carriage, and purge bin are mounted within an assembly known as the presenter core. A nose assembly is mounted to either the front or rear of the presenter core and extends into the fascia. There are several other important components mounted directly to this assembly. The white clamp cam and the larger black clamp cam on the opposite side move the carriage clamp into and out of the bill alignment module for stack operations. This motor is used to operate the cams. A CIC sensor inside of this cover is used to track the position of the cams. Tracks for front-to-back movement of the carriage are located at the top of the side frames. There are gear teeth at the top running from end to end down the channel. There are 2 small flags on the right side track. These are used in conjunction with a sensor on the carriage. They are used to align the carriage over the reject and retract bins. A third flag, located in the nose, is used to align the front of the carriage to the fascia opening. Also located on the side frame is the carriage home sensor. The arrow on this cover aligns to the CIC target on the carriage. This carriage needs to be in the home position when the clamp opens and lowers into the BAM. The latch sensor confirms that the purge bin latch is closed. The rail latch sensor confirms that the S2 is racked into its operational position. The purge bin switch is located at the back of the purge bin opening. There is one final component in the presenter core that requires mention. A vacuum sensor is located near the top end of the vacuum subsystem, connected via a T above the filter. The purpose of this sensor is to ensure that the vacuum system provides adequate pressure for picking notes from the cassettes. The last area of focus for this segment is the electrical subsystem for the S2. While there are various interconnecting circuit boards and special purpose circuit boards located on the S2 subassemblies, all of the command and control for the unit is centralized at the main control board. This is the brain of the S2. There are 17 connectors on the control board. The function of these connectors and a complete electrical distribution diagram is contained in the S2 service manual.